Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please just use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Image Scanning Best Practices for Containers and Kubernetes. Our speakers today are Knox Anderson, who is Director of Product Management at Sysdig, and Pavan Shankar, who is Director of Product Marketing at Sysdig. Thank you guys for joining me today. Welcome.
Thank you guys. Welcome everyone to this webinar. We have an exciting topic, as Charlene mentioned, around image scanning, best practices for your containers and Kubernetes environments. And as Charlene mentioned, if you have any questions during this webinar, please ask them in the questions panel. And also there are some fantastic resources, blogs, and other links. If you have any more questions, you can follow up with that as well. So let's get started. Next slide. All right, on tap today, we have an exciting agenda. We'll go over some of the requirements around image scanning, talk through some of the best practices that you can adopt today in production, as well as cover a overview of Sysdig and go through a live demo, and then stick around for some Q&A to answer any questions that you might have. So let's jump into why image scanning in the first place. So typically, what does a DevOps workflow look like in today's environment? So if I'm a developer, I typically commit code into GitHub. That code is picked up by your CI/CD tool, like Jenkins, for example, that picks up the code, the binaries and packages, and builds the container, which then goes through a staging environment and then ultimately gets deployed in production. And you might have some existing monitoring tools like Prometheus to monitor your environment. And this is typically your application lifecycle, but where does security come in? And to answer that, typically it comes in late after the application deployment. And as security comes in, the security teams are starting to implement the security policies and are not informed in terms of the development of the application and don't come in early. And this is an issue because let's say a bug is found in the last stage after deployment. Now the bug is found by your security teams, and to inform your developer, that developer might have moved on to a different module, different project, and the timeline for resolving those issues takes a long time. So this requires your dev team to switch context, come back, relearn the environment, and takes time to remediate some of these issues. So ultimately, this slows down your developers from pushing applications to the cloud fast, and ultimately can also slow down your container and Kubernetes adoption in your organization if you are blocked by security and compliance. Now, what are some of the consequences of security coming in late? So one of the key implications of this is that a lot of times, like we just discussed, vulnerabilities are not addressed early and early in the life cycle and before deployment. And solving and resolving this bug or vulnerability in your environment requires organizational changes between security and DevOps. And to address this takes a lot of time. And a lot of times teams don't even know who owns the fix in the first place. One of the stats that we collected from our container usage report last year found that over 52% of images with high severity fail scans, ultimately leaving your applications exposed to potential attacks and vulnerabilities. In addition to that, people think about image scanning as the first step, but that's not the only element of security, you also need to have some sort of runtime security and incident response in place. And what we found from our analysis was a lot of times teams don't have best practices for runtime detection and prevention. And on average, we found over 21 containers per node were running as root, opening the door for potential container breakouts. And finally, most container breaches are often undetected. And what we found was, on average, over 52% of containers live less than 5 minutes, which makes things such as incident response, audit, and forensics really challenging when these containers are ephemeral. So, taking a step back, security coming in late allows you, results in a lot of negative consequences where you can't detect vulnerabilities quickly enough, you don't have the right best practices, you might be failing compliance audits, and ultimately can't detect incidents when they do occur. So taking a step back, what does a secure workflow across this lifecycle look like? And this starts typically with securing the build phase, but also ensuring that you have runtime security and a response framework in place as well. So in the build phase, embedding scanning to detect vulnerabilities as well as misconfigurations, ensuring your developers are following best practices as early as possible is the first step. But also ensuring that you have the right runtime security in place, both detection and prevention, and also security monitoring to continuously catch drift or new zero-day vulnerabilities or other anomalous activity at runtime. And finally, responding to alerts and having forensics audit mechanisms to detect and respond to breaches is something that's important as well. So embedding the security across this lifecycle is what we call a secure DevOps workflow. So now let's go into some of the practical examples of what are some of these best practices you can follow when it comes to image scanning. So as we discussed earlier, the first problem that we are typically seeing developers face is that security is often coming in late. And now the first best practice to adopt is embedding scanning into your CI/CD pipelines and integrating with tools like Jenkins and blocking builds if they don't meet security and compliance guidelines provided by those security stakeholders in your organization. And as we saw earlier, scanning early and reporting on that failed build directly in the pipeline itself is key to ensuring your developers can immediately see exactly why their build failed, right? And then rebuilding the image with the appropriate fixes allows them to ship applications fast. And when security comes in late, this takes a lot of time. Vulnerabilities can be exposed, leaving room for a lot of attackers to access your environment. So shifting the security left allows you to maximize security and compliance, and also ensure that you're deploying applications fast. So this is the first best practice. Now, Knox, why don't you tell us about another best practice to adopt when scanning containers in your environment?
Thanks, Pavan. So one of the other key things when integrating scanning within your pipeline is to do it inline. So what we mean here is having the ability to scan the image locally on the Jenkins node or whatever you're using as your CI/CD tool of choice before it's pushed to the registry. Typically, a lot of scanning happens in the registry, but if you're able to integrate it inline directly on the build system, it allows you to have that registry be much cleaner because you're only pushing what has passed. And then it also just solves a lot of specific networking issues that you might be facing where having to expose a registry so a scanning tool can access it, or if you have many different build tools that are living within different clusters, it can get pretty insecure if you have to expose scanning tools to those specific environments. And so the ability to integrate it natively within the CI pipeline before the image is actually pushed as an artifact really cuts down on a lot of the costs and the time, and just makes your registry a lot cleaner from that perspective.
And talking about registries, like Knox mentioned, by scanning images there, you at least know that they've been scanned before running. So whether it's a private repo or a public repo, and when possible, use private. Scanning there allows you to ensure that you have the right security mechanisms in place, And this is also why a lot of cloud providers have registry scanning in ECR, DCR, for example, to detect and catch these vulnerabilities that might be baked into your images that are sitting in the registry. And you can also extend this further with inline scanning, for example, in the registry. So as soon as you push an image, it's scanned automatically without your developer interaction. And this allows you to ensure that sensitive information never leaves your AWS account. So your image contents or registry credentials is within your own environment, and you have access to that data. And also, you can directly see the results within the repo interface.
And another point on the registry side is one of the benefits of containers is you can pull public images that are built outside of your organization. So that's an area where you wouldn't be able to bake it into the CI/CD. And so having scanning within the registry ensures that even images built outside your organization are scanned before they're deployed. One of the other gates that you can put in place, specifically if you're using Kubernetes, is using an admission controller. So an admission controller will allow you to do a validation against a Kubernetes object after that request has been authenticated, but before it's been persisted to the cluster. So from a scanning perspective, this will allow you to start to kind of put a pre-production gate in place to answer questions like, if my image is unscanned, I don't want it to run in production. Or if this image has been scanned and it's failed its policy evaluation, don't allow it to run. The nice thing here is this will allow you to validate against any image that's being listed in the pod spec. So whether it's a public image or whether it's an image that you and your teams have created, the Kubernetes admission controller can serve as kind of a gate that's in place before any workload is started within your Kubernetes cluster. Admission controllers you can also use for things outside of scanning to verify users or permissions on the pod as well. So I'm seeing a lot of interest in admission controllers with our customers, as well as integrating with other open source tools like OPA on that side.
Yeah, and that's a great point, Knox. And what we're seeing more and more is, as images are being deployed, a lot of times the image you scan is not the same one you deploy in your cluster. And this can potentially happen when you use mutable tags like latest or staging, for example. And these tags are constantly updated with newer versions, just making it harder to know if the latest scan results are still valid, and also potentially cause problems when you're trying to debug. So what can you do from an image scanning perspective to ensure that these kinds of drift don't occur? You can enforce this policy via a combination of Kubernetes admissions controller, like Knox mentioned, your image scanner, and also using OPA to the point described before in the previous slide, where you can use that for more of the advanced policy decisions.
And then one of the other nice things about kind of containers and images are the common bases that you build your applications on top of. So it could be Debian version 10, it could be Alpine, it could be UBI from Red Hat, it could be a RHEL image, and those different applications are built on a standard base. One of the key things that we see customers tracking and making sure that they understand is, okay, which images are built on this specific base version. If I upgrade from Debian 9 to Debian 10, what new vulnerabilities are going to be introduced, which ones have been removed. So really make sure you understand which bases your different images are using, and then the applications that are built on top of them. So on the base image side, make sure you're scanning for these OS vulnerabilities, monitoring what has a fix, and then upgrading your bases kind of all in one swoop, and making sure you have good Dockerfile hygiene on that side.
Yeah, and to build on Knox's point, a lot of times DevOps teams understand that scanning for OS packages and for vulnerabilities in them is important, because if these vulnerabilities are exploited, they can potentially bring down your applications, and which is why a lot of cloud providers embed OS scanning inside their environments. and why a lot of these vulnerabilities, there's a very small amount of higher critical vulnerabilities that we see in these environments. But often teams don't check for vulnerabilities in the third-party libraries, which can also unknowingly incur risk in your environment, because developers might be pulling in vulnerabilities from these non-OS open source packages like Python pip, Ruby gem, Java jar, for example, and these can add vulnerabilities that you might not even know of. So ensuring that your scanning tool can detect non-OS vulnerabilities. A great feed is from VulnDB, for example, that can provide more rich data about non-OS package vulnerabilities.
One of the other key things to pay attention to when you're using containers is to make use of lightweight base images. So this would be something like a distroless image or an Alpine image that are specifically made for containers. A lot of the other bases are around as base distributions that you have used historically on VMs or other Linux environments. So by using something like Alpine or using something like distroless, you're really limiting what's included in that base. So that improves a lot of the signal to noise that you would see around the specific vulnerabilities that are in the image. One of the things we've seen a lot of customers have success with is rebasing, and so it becomes a really clear business decision of kind of switching to something like Alpine, and you can immediately see the differences in terms of both the image size and the packages and vulnerabilities that are included in that image. One of the other interesting kind of bases that's come out recently is the universal base image from Red Hat. It's something that you can distribute but still have under your Red Hat support contract. So both UBI, Alpine, and distroless are all good options to go forward with.
So Knox and I have talked a lot about scanning for vulnerabilities, but as we mentioned earlier, when we take a step back, you want to make sure that you're detecting not just vulnerabilities but also misconfigurations in the build phase. And there are several Dockerfile best practices you can follow to detect common misconfigurations that your developers might be unknowingly introducing in your environment. For example, are they running as a privileged user with access to more resources than needed? Are they exposing ports like SSH that shouldn't be open on containers? Are they, including private files accidentally via a bad copy or an add command, or just running a large image, which can have take a longer time to deploy on your cluster, but also be a larger attack surface. So fortunately, most of these best practices are covered by standards like NIST or PCI that have some compliance controls that you can map to. And many image scanning tools also provide a lot of out-of-the-box policies that have been mapped to not just the controls, but also Dockerfile best practices, so that you can introduce security early and get up and running quickly and make sure that you don't have these sort of misconfigurations that you could have that are classified as low-hanging fruit.
And then kind of one of the main challenges in kind of vulnerability management in the Kubernetes space is, hey, I've got this this Redis image. It's used by 10 different services across 5 different clusters. What's actually affected? So one of the key things to do is to take in that Kubernetes context, understand where that image is running, so that you can really prioritize kind of what you want to fix and the specific impact of that fix. So the ability to then go back to a dev team and say, hey, you're in charge of this namespace, this image that you're using has been affected, really gives them more context, and it's going to save a lot of time on your side where you can prioritize what's most important based on the labels that are exposed from Kubernetes itself.
Great, and we covered 10 best practices, but just a bonus one to throw out there is just to leverage a SaaS-based solution, which helps you be more efficient and deploy apps faster. And this allows your dev team ultimately to spend more time on developing applications and less time on operational issues. And some of the benefits of using SaaS, is, for example, it's on demand and scalable. So you can start with scanning a few images at first, and typically this is what we see, with Sysdig as teams onboard with image scanning. They start with scanning a couple images, and as they feel more comfortable and as their environment and applications grow, they can scale with the security solution as well without having to worry about any of the data back-end management. It also has faster implementation, so you can embed scanning into your pipeline and get up and running in minutes, versus an on-prem solution that might take you more time to just install and set up and work with different parties to get that going in your environment. Another really big benefit of SaaS is just easy upgrades and maintenance. So as a SaaS provider rolls out new features, that gets pushed to your environment without having you to manually upgrade. And this is a huge benefit that we see in a lot of our customers, where we're handling a lot of the feature rollouts and patches for them, and then they get the value from the product, which is security. And finally, there's no infrastructure or staff costs associated with just keeping up, and you're just reducing TCO here with the SaaS-based solution. So that being said, we've covered about 10 to 11 best practices for image scanning. So let's just tie this all together in a demo. And Knox, why don't you show us a little bit about how Sysdig addresses a lot of these security issues and provides some of these best practices out of the box.
Awesome, thanks, Bowman. And I'm going to just answer one question that's come in before getting into the demo. So Venkata asks, how much should we trust images from well-trusted sources like Google or Red Hat? Do we still need to maintain custom tools for scanning on the images from these sources? Great question there. Claire, which is a scanner offered by Red Hat, and then Google has a scanner built into GCR. Those are more focused on the OS packages. So if you want to identify vulnerabilities in some of the non-OS packages, that would be something where you would want to use another tool for scanning. And then potentially some of the workflows around monitoring which images are being deployed into runtime, what's their vulnerability posture, and those types of things are areas that we can cover today that would require kind of a solution outside of what Google or Red Hat would provide. In terms of using basis though, I think always trying to stick to something like the Google distrolist images or the Red Hat UBI images as the base that you pin on and follow up there is a great practice to follow. So to hop into the demo, what we're looking at now is just a quick overview of the system. I can easily see the images that have been scanned over the past couple days, what's passing or it's failing, for the images actively running in my environment, what's that posture, how it's trending over time, as well as CVE details and runtime policy events, like a user spawning a shell in a container, or someone updating a config map that has private credentials, those types of activities that have happened there as well. So now let's get into kind of the typical steps an organization will take to ensure that they're building secure, reliable images. So using some of the scanning policies in Sysdig Secure, you can actually shift your patch lifecycle left. So you can build a policy that says something like, if there's a high severity vulnerability with a fix available and that fix has been out for more than 14 days, fail to build. One of the things that we see a lot of people trying to do is kind of enforce these patch windows. It's a whole lot harder to do that once something is already running in production. So the ability to kind of key in on that fix information, if it's available and how long that fix has been out within the CI/CD pipeline makes it a lot easier for developers to address these issues. Also, by using this fix field, you're only alerting on something that's actionable and there is a fix available, which is one of the things that kind of saves a lot of time there. You can also look for things like, are there embedded access keys or secrets? Is the effective user root? Or operational things like, has a health check been created for this specific image? Touching on some of the areas Pavan had talked about before, with the Dockerfile best practices, you can ensure that you're using proper labels. So if someone is labeling their image as latest, warning on that. Also, one of the things that we see a lot of with organizations when they're starting off on their container journey is in the run instruction, they might have something like a yum upgrade. The problem there is if you're just running yum upgrade, a bunch of packages are getting updated automatically. You don't really have control of what's being built in that image. And so it's really hard to reproduce version to version what's going on there. So from a best practice perspective, you'd want to flag something like that. Things like, have you created a user? Are you using add rather than copy? Other things around having proper image hygiene on that side. And then, like Pavan had mentioned, on the compliance side, also going in and validating against things like NIST 800-190 really early to check to see areas around environment variables, different ports that are exposed, allow you to ensure a lot of these configuration and compliance questions before images are deployed. For any one of these steps, you can choose if you want to stop or warn, which allows you to kind of give the right data that you need to have exposed within your build tool of choice. So once you've built a secure, reliable image, the next thing a lot of organizations have questions about is, okay, how do I monitor what's actively running in my environment and what's the status of those different images? So here we can look at a specific Kubernetes cluster. I can see all the images that are running in that cluster, what's passing or failing. But in Kubernetes, you spin, you have different teams that are managing different resources. So here we're looking at it in a node-based view. I can see the different nodes in my cluster, what's passing or what's failing there. But what you might want to look at is from something like a deployment perspective. So here we can look at that same Kubernetes cluster. I can then see all my different namespaces and drill into that namespace. So here I'm getting a logical view for a specific application. I can see the different images that have been deployed there and what's passing or failing from a scanning perspective. So this really allows you to get that developer or that service-centric view of the images that are running in your environment and the ability to understand your posture on that side. This is another area where kind of alerting and sharing that information with your developers is key. So one of the things that we see a lot of organizations set up is something like, if I see an image that was passing that's moved to a failing state running in a particular namespace, alert on that, and then send a Slack message, an email, a webhook, send it to Elasticsearch, whatever you want here around that specific event. Or things like a CVE update just as more informational. So one of the things you can alert on is anytime a CVE has been added, updated, or removed from an image, just get that data sent to the team that's responsible for that specific service. So once you've kind of handled scanning and the different environments there, one of the other kind of key things that we see from a lot of customers is kind of running different report queries. So if you want to either do it against a static or a runtime scope, being able to say, show me all OS vulnerabilities that are a critical severity and have a vulnerability that was detected before a specific date or one with a fix available. These types of queries you can run across vulnerabilities packages or those specific policy evaluations that have occurred for either static or runtime environments. On the runtime side, any of the different labels that you're using, you can run these queries against. So if you want to do it for an AWS region, a Kubernetes cluster, any container image tag, that's really flexible from a query perspective there. So moving a little bit past scanning, some of the other areas customers focus on is things like CIS benchmarking. So the ability to run a benchmark against a specific environment, see what's passing or failing there. So if we look at the Kubernetes master, for example, you can see how well you've configured something like your API server, what's passing, what's failing, and then remediation content for anything that has failed within that specific CIS benchmark check. All of this data we're also emitting as custom metrics. So if you want to monitor kind of how your compliance posture is changing over time, you'll have the ability to look at that for the last 90 days, 360 days. Here we're looking at a 90-day view across my entire infrastructure. And so one of the things, whenever you're going through any audit, you have to go in and say, yes, I've been running these CIS benchmarks every day. We're getting better over time. I have these results about how my images are configured, the specific runtime passing information here, and being able to just have this as evidence is something that makes it a lot easier on that side. So moving back into security, one of the other concerns that always comes up is runtime security and detecting different events that have happened in your environment. So all of the detection at Sysdig is built on top of our open source tool, Falco, which is kind of like if you had combined Snort and strace together. So it's looking at all the system calls that are happening or the Kubernetes audit log data and alerting on activity that's happened within that environment. So if we look at some out of the box rules, let's focus on the control plane first. So here I can look at my Kubernetes control plane, and maybe I want to alert on, hey, a new cluster role with write privileges has been created. So from a security perspective, now you have a new role that has privileged access across that cluster. So that's something that will you'll want to understand from a configuration management perspective, and then also maps to some of the controls within PCI around privileged access on that side. Moving from the control plane, you can also look at different things that have happened kind of more at the workload level. So if we wanted to look at something like, okay, if someone is launching a suspicious network tool in a container, you'd see something like there's a spawn process, it's in a container, and it's a network tool process. So here you'd see if someone is running something like TCP dump, tshark, incat inside a container, having the ability to alert on that type of behavior. All of this you can fully customize, really extend out to cover any process names, any file descriptor information, any ancestor processes. So from a detection perspective, basically anything that makes a system call or anything that ends up in the Kubernetes audit log, you can have rules and detections based on that data. We're also using this as a source for auditing. So kind of one of the key challenges that we see with a lot of customers is, okay, who's accessing this Kubernetes environment and what are they doing? So kind of one of the key challenges we see a lot of is someone cubes execs into a pod, everything they're doing as the root user, so you can't actually tie it down to a specific user or a specific action. So here we can just choose to filter on, show me all the cube exec activity that's happened in my environment, and then let's trace that specific session. So here we'll be able to see that cube exec session. If I isolate on that event, you can see the source IP that it came from, the user that started that exec session, the different groups they're a part of, and then within that specific session, any command that's executed, any network connection that happens from an interactive process, as well as any file modifications that have occurred. So that'll address a lot of the auditing around access, as well as a lot of the different file integrity monitoring requirements that you could have in something like PCI or SOC 2 on that side. And so to finish up, one of the things Pavan had talked about before is having a incident response plan and a workflow there. So let's take more of a kind of a classic example of, okay, someone has spawned a shell in a container. I want to figure out what's happened. So here we can see someone spawned a shell. It's in my AWS cluster. It's in the store front end deployment, so I might want to look a little bit closer there. And then other kind of key value labels that give you context around where the specific event occurred. all of this enrichment is automatically stored on the event. So if you forward it down to any SIM, you're not going to need to do additional enrichment there. So let's go in a little bit further and see what's happened in that specific terminal shell and container event. And here I can open up a Sysdig capture. The Sysdig's founder's previous project was Wireshark. So a lot of the same type of data collection that you would do with a packet capture, we can do with these Syscall captures and then open it up in the product. So here I'm opening up that Sysdig capture of all the activity that happened before, during, and after that specific event. This is really important because what Pavan mentioned earlier, containers are running less than 5 minutes. So by the time someone can actually go and investigate that incident, that container is often long gone. So here I can look at the specific time when that event occurred, then start to overlay things like modified files, access files, net bytes, some interactive commands to spot trends in my environment. And then we can go in and just isolate that specific time period. So if we're going in and looking at those executed commands, I can see someone curled down a package, untarded, and then shredded their batch history. So that's something that definitely looks a little suspicious here. So let's go look at which files and directories were introduced. But following that tar process, I can see all the different directories. I can navigate to something like the master directory, see all the specific files that were written, and then kind of one of the things that you can do here, which is similar to like a follow TCP stream, is go look at any of the IO activity that's happened around a specific file to then get a full understanding of what data was read, what data was written, and have all of this from an auditing, compliance, or incident response perspective. So hopefully that gives you kind of a quick overview of what you can do on the scanning side, what you can do from a runtime and auditing perspective, and then how you would tie that together with incident response. And then kind of there's always a lot of things that you have to learn as you start kind of with products. So one of the things that we've done for users is just have a simplified onboarding experience where you can easily see how you'd integrate scanning within your pipeline, set up different alerts to make sure you're covered and can get started quickly on that side. So now I'm going to pass it back over to Pavan to finish up around kind of a broader view of what we do at Sysdig.
Awesome, thanks Knox, that was an amazing demo. So jumping back into the slides and kind of wrapping this up a little bit, you know, at a 10,000 foot level, our mission here at Sysdig is to help teams like yourself run cloud native workloads in production with confidence. And, you know, the platform itself is open by design. So as Knox mentioned, founder was the co-creator of Wireshark. You know, we contributed Falco to the CNCF. Falco is something that we created back in 2016, and it's now a runtime security project and in the incubation phase, and has gained a lot of momentum. And in addition, the Sysdig open source has also been widely adopted by the community for troubleshooting and you know, digging into issues when they do occur. And from an ecosystem standpoint, you know, we play nicely with everybody. You know, teams call us the Switzerland in the space because we work and integrate tightly with the likes of Red Hat, Kubernetes, Rancher, the cloud providers like AWS, IBM, Azure. And also from a momentum standpoint, our customer expansion really mirrors their cloud native adoption. So working with the largest enterprises, the banks, the retails, as well as a lot of smaller companies and fast growth companies that have similar use cases around security, compliance, and monitoring. Next slide. So, you know, for Sysdig, our platform is called the Secure DevOps Platform, and we help DevOps teams embed security and validate compliance, maximize performance and availability, and help these teams get results quickly when they're running containers and Kubernetes in production. And we're built on an open source foundation, and we have two key products, Sysdig Secure and Sysdig Monitor that integrate into, together in a single platform called Sysdig Platform. And the reason for this is we believe that in order to help these cloud teams and DevOps teams ship applications faster, they need to embed both security and monitoring into their workflow. And this gives them better visibility and security and helps them spend more time on deploying apps rather than worrying about operational or security issues. Next slide. So we spent a lot of time talking about the platform, and in this webinar we really focus on security. So our key product here is Sysdig Secure, which helps DevOps and security teams manage security and compliance risk, and we really address security across the container and Kubernetes lifecycle. So we talked a lot about image scanning. So starting with in the build phase, scanning for vulnerabilities and misconfigurations, embedding scanning into your pipelines, into your registry, scanning locally to ensure more privacy and safety, and also reporting on vulnerabilities when they do occur based on the specific application, service, or cloud environment that you're deployed in. And then from a compliance standpoint, validating continuously with standards for PCI, NIST, as well as ensuring that you're following best practices based on CI's benchmarks for Docker, Kubernetes, and Linux as well. And then we covered a lot around runtime security and incident response, and this has been the bread and butter for a long time, where we can help detect threats based on our open source, Falco that's under the hood. And we also ensure that you can prevent threats without impacting performance by using the native controls in the fabric of Kubernetes itself. So using pod security policies allows you to enforce least privileged access without impacting any of the performance. And we also integrate with the Kubernetes API. So using audit logs allows us to have a richer source of detection that adds better detection capabilities on top of the Syscall events that we collect. And finally, as Knox talked a lot about our incident response and forensics workflow, so being able to conduct that even after the container is gone is huge for a lot of our customers, especially when these containers live for 10 seconds, 30, or less than 5 minutes, and having a full audit trail to see exactly who exited into a pod and see what commands they ran, what connections were made, did they tamper with any files. The whole data stream is something that's extremely useful as an audit tab for our customers and for the incident response workflows, and giving them more confidence in running containers in production. Next slide. And to kind of tie this all together, what we're seeing is as DevOps teams are getting started, they need a secure DevOps workflow to just understand how do they get started with security and monitoring. And what we offer is an essentials tier, which packages these 5 key workflows that are image scanning, runtime security, container and Kubernetes monitoring, application and cloud services monitoring, and compliance. So these teams can get started in less than 5 minutes with these workflows. And as they start to mature, they can incorporate some of the more advanced workflows that are the threat prevention, the machine learning-based anomaly detection, some advanced troubleshooting, the incident response and forensics that we showed you, as well as extended compliance controls that makes a lot of sense for these teams as they are scaling and require these additional capabilities. So the key thing here is, Sysdig addresses the use cases and needs for teams that are just getting started, as well as when they're scaling up without impacting the performance or the stability in the environment. So that sums it up. And what we have, for you, if you like the content that we talked about, if you got excited about the demo that Knox did, and if you're thinking, okay, now what do I do next? Well, we have a free trial, a 30-day free trial available for you that you can easily access for the Sysdig platform. So both Sysdig Secure and Monitor, or if you're saying, I just want to see Secure first or Monitor first, you can do that as well. And it's free for 30 days. There's no credit card required, and you can easily sign up on the website at sysdig.com/company/free trial. And next slide. And if you like the content and if you want to sign up for more, we have a lot of our webinars live that you can register for on sysdig.com/webinars. And also if you can't make them, we also have them on demand available for you. So they'll just be emailed after you register. But here's a a quick lineup of some interesting webinars that's coming. July 30th, we have a Secure DevOps virtual meetup in Europe. So this is a EMEA-focused webinar with a guest from Red Hat. And then August 6th, we have a webinar around automating container security, monitoring and compliance with a Dutch service provider that talks a lot about their experience with Kubernetes and how they leveraged Sysdig to help them for their security and monitoring workflows. And finally, August 13th, we have a topic around instrumenting apps with Prometheus. So if you are also interested in getting started and scaling Prometheus, we have the author of the Prometheus Up and Running book, Brian Brazil, that walks through the basics to get started, and we'll have an in-depth conversation there as well. Great. So that being said, we'll the content for this webinar is complete, and now we'll move over to the Q&A section to answer any questions that you might have.
Excellent, excellent. Well, yes, we have about 10 minutes or so for question and answer period. So if you have a question, please go ahead and use your GoToWebinar control panel and get it on in there. Here's your first question. What types of checks can be part of an image scanning policy in Sysdig?
Yeah, that's a great question, and Knox had shown that earlier in the demo as well. But we can just kind of sum it up: detect vulnerabilities and misconfigurations in that single UI. So scanning for vulnerabilities in your OS packages, your third-party libraries, adding more advanced conditions to say if a high severity CV with the fix available is running, block the build, as well as misconfigurations. So some exposures in your Dockerfile, SSH being exposed, somebody embedding secrets, AWS access keys, license checks, metadata about the image, all these different parameters and rules and triggers that we can check for are all baked into the policy. And we have a lot of these out of the box as well. So you can get up and running quickly with an out of the box policy for Dockerfile best practices, as well as some of the compliance standards like PCI and NIST.
Excellent. Okay, next question here. Where do the scans typically occur?
Yeah, that's also a great question. So as Knox talked a little bit about our scanning, we scan in the pipeline. So we have a native plugin for Jenkins, and we support other CI tools via API integrations. We scan the registry. We also support inline scanning, so scanning on the same node as the pipeline, as well as we have a node analyzer that allows us to scan any image that's running and send those scan results back to the back end to be able to see all of those results in Sysdig Secure.
And yeah, so it looks like a bunch of questions have come in the last couple of minutes. So I'll try to go through the quick ones fast. So do you support Azure DevOps? Yes, full support for Azure DevOps. We have a blog that we can follow up that has a reference integration within Azure DevOps. Another question was around how often do we get updates from CVEs, and is there any limit of scans for the free or paid subscriptions? We are getting the feed updates roughly every 4 hours, and then that's something that as the SaaS product, you're getting all those updates. If you're using our on-prem offering, then you can either run us in an air-gapped mode or proxy out to our SaaS feed to get those updates at that same interval. In terms of limits, the enterprise product is unlimited, and then essentials we're limiting to 100 scans a day in terms of just images that are added on that side. Another question from Davel around Sysdig using Ancor as the core for Docker security. Ancor is kind of one of the engines that we use. So Ancor performs scanning on the runtime side. We're doing that with our Sysdig agent and Falco, which was a security project that was created here at Sysdig and then donated to the CNCF. That's part of the open source kind of landscape there. We've extended kind of what you get from Ancor to also include a lot of the runtime use cases by mapping the digests that are agencies, so the ability to do all of that runtime reporting, alerting on changes, and then kind of, I'd say one of the other differences with Ancor is we operate a SaaS service, so that's kind of some more details on that side.
All right, great. Plenty of time for questions, guys. We have about 5 more minutes, so if you do have a question, go ahead and get it on in. Knox, I'm not quite sure, actually answered this question. Would you recommend performance checks as part of image scanning?
Totally. So that's something where, and by performance checks, maybe you're checking the size of the image, or you're checking the workload impact, or things like that. So I think maybe if we could get a little bit more details on that question from Subo. Davel had another good question around, for scanning during CI/CD, does it upload the image metadata to the Sysdig platform? Does it upload the image data to the Sysdig platform, or does it just send metadata to Sysdig for analysis? We have both options. So if you're just adding the image to our SaaS platform, the analysis will happen in the backend. But if you use the inline scanner, it does all of the analysis locally within your environment, and then just sends us a image artifact that includes metadata about the packages, the file content, and that kind of information. So it's not actually sending out the full image there. And then from a Sysdig platform perspective, you can use us as SaaS or self-hosted there.
All right, great. Let's see. Danielle actually put in a question: is AV malware scanning incorporated in the workflow, and what is the best practice?
So this is something we haven't seen much in the wild around malware being something that's in containers. From a malware perspective, though, we do store an index of all file hashes for the image. So if you have your own kind of malware feeds that you're using, you can verify the hashes that are in the image, and then against that malware feed that you might already have. That's something we're also looking at incorporating as more of a native function, but we do store all file hash content for every single image.
All right, great. Another question here: do you have any suggestions or inbuilt process to auto-recover from containers that were infected during runtime?
On the alerting side, this is something where you can receive those types of alerts. You can then choose to trigger like a rebuild based on a webhook. So that's something we've seen probably a couple customers that are more advanced in using the API, doing something like that, where if an image has moved from a passing state to a failing state, trigger another build of the image to see if something else has changed. But in terms of scanning, it would be pretty dangerous to take actions based on CVEs, because CVEs happen all the time. Related to runtime events, like if someone shells into a container or starts running suspicious network tools, things like that, you can take actions like stopping, pausing, or killing that container as an automated action as part of the policy evaluation.
All right, great. I think we have time for 2 more questions here before we close down question and answer period. Are dashboards customizable, like reports, status, things like that?
Yep, all the dashboards are fully customizable.
All right, great. And let's see, would it be possible to send the scan results to Elasticsearch?
On the scan results side, we have native event forwarding. So that's something where if you can forward out via syslog, and we also have a REST API that you can pull data from as well.
All right, great. All right, let's see, how do you integrate with Kubernetes admissions controllers and OPA?
Pavan, do you want to take this one?
Yeah, sure. So we can integrate with the Kubernetes admissions controller. So via a validating webhook, you can prevent the deployment of any image that does not pass those security policies that you might have that you created. And this allows you to verify the governance and ensure that those images are being deployed based on the policies. And then for advanced policy decisions, we also integrate with OPA. So you can incorporate to say, have a more permissive policy for a dev cluster, but for a namespace that's more sensitive, maybe a credit card namespace, that can have a different policy, and you can enforce that via the OPA integration.
All right, great. Well, we are about 5 minutes to the top of the hour, so unfortunately that's all the time we have for the question and answer period. If we did not get to your question, I apologize, but please know that the folks at Sysdig will be getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also want to remind the audience that today's event has been recorded, so if you missed any or all of the event, you will have the opportunity to watch it again. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, before we close things out, I do want to do the drawing for the 4 $25 Amazon gift cards. So without further ado, our winners today are Ariel H, congratulations, Ariel. Blair C, congratulations, Blair. Don K, congratulations, Don. And our final winner today is Jeffrey W. Congratulations, Jeffrey. We will be following up with all 4 of you offline by email to get your gift card over to you, so please check your inbox. If you don't see it in your inbox, please check your spam folder. Knox and Pavan, thank you both for a great presentation today. Lots of really interesting stuff. Really appreciate it.
Thanks, our pleasure.
All right, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Please stay safe.